Hi, sixth graders. It's Miss Reynolds, and I am trying to help you with your homework because we didn't have a lot of time to look at it. So let's just take a look um, at what we got here. Okay. So this is on the back of the page that we did today. I did not mean that you had to do this, so this is a good place for me to start as an example. So the first thing I want to do, remember, I'm trying to get this sum to have a greatest common factor that I put here, and to have two remaining factors that I add together. Okay, this is the way we want to rewrite it so that it is equivalent to that's a better parentheses, to the sum of 6 plus 10. So the first thing I need to do is find my greatest common factor, right? And I do that with a ladder. So you start by saying what goes into 6 that also goes into 10. Okay, well, 2, because they're both even numbers, right? So 2 times what is 6? 2 times 3. Okay, and 2 times what is 10? Well, 5. Now, remember, we're adding these together, so I can just go ahead and drop down my little addition. Okay, so now I know my greatest common factor is on the side, and there's only one number, so it's just that number. If there was more than one number, I would have to multiply them, right? Okay, so now what this is telling me is that the two arrays are going to share a side of 2, okay? The first array is going to have 6 total squares. So it is going to be 2 times 3. Okay, so here's the 3. Okay, so I'm going to go 3. 1, 2, 3. That's my first array. It should be 6, right? Yes, there it is, 6. Okay. My other array will also have a 2, but I'm trying to make 10 with it, right? So if I'm taking a 2 right here and I'm trying to get 10, I'm going to have to multiply it by 5. So that'd be 1, 2, 3, 4, 5. Okay. So now if I complete the rectangle, oops, sorry. If I complete my rectangle, I'm going to put a 5 up here. I should have 2 times 5, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. How did I make it 10? I took the greatest common factor right here. So I knew one side was 2, and to make 10, it has to be 2 times 5. That's how I did that, right? Okay. So there's my array. So now what is my greatest common factor? It is 2, right? Okay. Now, what can I write inside the parentheses? Well, instead of doing 6 plus 10, I can say, well, I could just take this entire side over here, which is 3 plus 5, right? 3 plus 5. And look where else that is. It's on my ladder. 3 right here and 5. We'll do that one in orange so you can see the difference. Okay? So if you do the ladder correctly, it fills in exactly. This will be your greatest common factor on the outside. And on the inside, you have the sum, which means adding, of the two remaining factors. Okay? All right. So now let's look at the model. Okay? So right now, I see 1, 2, 3, 4, 5. That means the side across from it is also going to be 5. 1, 2, 3, 4, 5, because it's a rectangle, right? That tells me that 5 is the common factor that they're sharing. Should be the greatest common factor, but I don't know yet, so I'm going to hold off on saying it is. Okay. Now, how many across is this? One, two, three, right? So this is a 5 by 3. Well, that equals 15, right? Okay. So my numbers I'm adding are 15. And then what is the red array? Let's go over there and look. Let me use maybe blue to write on it, would show up best. Okay, so remember it's 1, 2, 3, 4, 5 still. 5 times what? 1, 2, 3, 4, 5. Oh, it is a 5 by 5. Okay. Well, 5, these 5 times that 5 across here is 25 squares. Okay, so what are the two numbers that I'm adding? The addition expression is going to be 15 plus 25, right? Okay. If I can write it correctly. Now, when I do a ladder, let's look. They shared the side of 5. Each rectangle had a side of 5, right? So that supposedly is the greatest common factor. Let's make sure. If I factor out the 5, what's left? A 3 and another 5. Can I, are 3 and 5 multiples of the same number? No, I cannot divide them by the same number. So I'm done. And 5 is my greatest common factor, right? Okay. Okay. So that goes on that first line outside of the parentheses. Okay. Now I'm going to have my parentheses. What goes inside the parentheses? Well, on the model, it's the other side that's not 5. 3 and 5, right? Sorry, y'all hear a lot of extra noise out in the hall. I did not close my door. Okay. Now, if I want to tie back to, I'll use green. If I want to tie back to the ladder, the greatest common factor on the ladder goes first, and I can multiply that greatest common factor times the sum of the leftover factors, 3 and 5, right? Okay. So if you have the model, you want to count how many squares you have by doing an array, and then the side they share is supposed to be their greatest common factor if they've done it right. Okay? Okay, so we've done one where we had the numbers. Here we had 6 plus 10. We've done one where we've had the model. Now let's do one where we have right here the distributive property. Okay, I really like it when I have this because it tells me their greatest common factor as long as these two numbers don't have one. And 3 and 5 do not have a common factor other than 1, right? So it tells me their greatest common factor. It tells me they share the side of 6. 1, 2, 3, 4, 5, 6. Okay. Then it tells me the side of the first one up here is 3. 1, 2, 3. Now, this is not nearly as good as you can probably do with the pencil. Okay. The other rectangle also has the 6, right? That's the side they share, their greatest common factor. And then it also has 5 on the top. 1, 2, 3, 4, 5. It did, I shouldn't have said also. It has 5 across the top. Okay. So now I know I have a 6 here, which means I also have a 6 on this side, right? And then I know I have a 3 here. And so 6 times 3, that means there are 18 squares in here. So I'm adding 18. What's the other number I'm adding over here? Well, this was 6, and across the top was 5. So this 6 times this 5 is 30. So I'm adding 18 plus 30. And when I do that, they should have the greatest common factor of 6, which they do, this side. And it left, if I did a ladder, which you don't need to do, but if you did, you would have the 6 and you would have the 3 and the 5 down here, and those would go just right into your new expression. Okay? So now I haven't talked to y'all about checking your work yet, right? So let's check our work. So let's take what we were adding. Oops, sorry, 18 plus 30, right? What is 18 plus 30? Well, I'm going to break apart the 18. I'm going to do 30 plus 10. That's 40. And then add this 8. So that's 48, right? Okay. We're going to prove that over here, this expression is equivalent. Here's how I do it. Inside the parentheses, I have 3 plus 5. That is 8, right? The parentheses mean multiply, right? So 6 times 8. What is 6 times 8? 48. So that's how I know they are for sure equivalent, right? Okay. So this is 48. Whoop. And this is 48. So they are equivalent. Okay. Now, look. So when you have the two add-ins, you want to do your ladder. That tells you their GCF and what's left over, right? The GCF is how long the side is on the model, right? Okay. If you have the model, it should tell you the GCF. The model should tell you the side they share, the same length, should be their GCF. That would give you this, right? Then their remaining sides should give you this. Okay? To get what they add to, it's how many squares are here, the green, that's the first number. And then you're going to add them to how many squares are blue, that's the second number, and that would give you the total number of squares, right? Okay, and remember, what do you do when you have the distributive property form already? Well, you can make your model, right? Or you can say, well, take the greatest common factor and multiply it times the first number. What is that? That gives you the number of squares. Then take the greatest common factor and multiply it times the second number. That's going to give you the second number, and then you're adding them, right? Okay? And remember, this greatest common factor, the 4, tells you how long their shared side is. It's going to be 4, right? Okay. So I hope that's going to help you with this homework.